So for our third presentation regarding AI issues, which very helpfully intersects also with our third topic and later presentations regarding cybersecurity, Dan Guido, co-founder and CEO of Trail of Bits, will be presenting an impact assessment of the proliferation of AI cybersecurity capabilities on financial security. Dan, over to you.
Thanks, Carol. So as if we weren't all concerned enough about AI, I wanted to throw a curveball. So Trail of Bits is a cybersecurity research and development firm. We help companies identify, exploit, and mitigate cybersecurity risks within their firms. And we specialize in emerging technology. So there are really very few other people in the world that are as capable as us as identifying how hackers can hack better with AI and what systemic risks that might have on the financial security industry, on the finance industry. So from my perspective, the availability of these models should cause us to reassess the defensive techniques that we apply, because the cost for attackers to perform certain attacks will change dramatically with the availability of these techniques. Normally, attack and defense, they're somewhat static. We have an equilibrium. We sort of know what exists, and it's a defined number of defenses we need to implement. But we're entering a period of much more extreme turbulence where we don't actually know what these models are capable of. And there are some initial results that it may actually dramatically affect the ability of hackers to be effective. So slide two. Oh, we're way beyond where I go back. My slides are off. Thanks, slide 2 is great. Okay, amazing. From the outsider's perspective, or from a non-expert's perspective, it can be really hard to figure out what's accurate. You have a lot of proponents that are saying that AI is going to usher in some kind of utopia, or that it's going to kill us all. On the other hand, you've got a lot of people that are claiming that this is just big tech puffery, that there's nothing here, it lies all the time, it can't produce any sort of realistic results for anybody, that it's a giant waste of time. We see this in the security industry as well. You've got security researchers that plug a piece of code into it, like the screenshot, they drop an Ethereum contract in it, and it immediately found a security vulnerability. On the other hand, you've got a consulting firm that says, oh, we tried that for ChatGPT, doesn't work at all, completely misdirects you, you shouldn't use it, period. And sometimes you've got companies that are both saying one thing and the other at the same time, like OpenAI. The thing is that a lot of these people, first off, aren't evaluating the technology in the way that I think we should. On the left here, one of those proponents didn't realize that the data that they were testing it against, the Ethereum contract with the vulnerability in it, was in the training data set. That all they were asking was the AI to regurgitate information that it had previously memorized. On the other hand, I think a lot of people are looking at AI to be magic, like some Jedi mind trick that can immediately discover a security vulnerability with the simplest of prompts. But that's also not how this will work. We already have general human intelligence. We already have general artificial intelligence, or not artificial. We have general intelligence. We have humans. Humans can be accelerated dramatically by taking good advantage of these sorts of techniques. What is a mid-level? Is it possible for a mid-level engineer to operate as an expert with the addition of AI techniques? That's really the question that I want to understand. So next slide. At Trail of Bits, we've tried to do this. So I have some empirical results from experiments that we have run internally to see how this will help our ability to identify, exploit, and mitigate security vulnerabilities. We had to realize a few things first. We had to understand that AI is not magic. It's just another tool in our tool set, and that we have to apply it to the right problems. We had to learn how to use the technology. We couldn't just ask it, please find the bug for me. It's not magic. You have to figure out things like chain of thought prompting and asking an AI to explain your reasoning, or a lot of the other prompt engineering techniques that I think people have now started to discuss. We also have to evaluate progress correctly. We need a benchmark against which we can decide if this is actually helping us or not. There are, again, many different tools that we can choose to use. Is this better than the state of the art? Is there something else I could use that's algorithmic in nature that instantly gets me the answer? What's the bar for progress? And then we had to choose the right problems, because AI, I think a lot of people probably tried to ask ChatGPT for help with their math homework. And they realized that it's really not good at that because that requires correctness. But there are lots of problems that security researchers work on that don't require correctness, that require breadth of knowledge, that require where mistakes are acceptable. So with that, we've been able to use it to decompile code into high-level languages that we could never do before. We've gotten it to identify and trigger software security vulnerabilities that are present in browsers. We can use it to greatly accelerate the offensive capabilities of a mid-level cybersecurity engineer. So let's go next slide. So from a sort of anecdotal perspective, this is how we think about it, where we've evaluated the efficacy of AI in the life cycle of a cybersecurity engineer. We look at problems that require breadth and where mistakes are acceptable as the best opportunities to first apply it. Things like documenting a function, where there's probably no documentation for it before. You can use that to audit a code base more quickly. If you have a code base of 10 million lines of code and you want to very quickly understand some broad information about it, AI is phenomenal because even if it makes some mistakes, it at least points you in the right direction. Phishing emails, another really great one, which I'll tell a funny story about in a minute. But I think a lot of people realize that the ability to develop, to write human language at speed and scale is something that is a brand new capability for the world that didn't exist before these were available, before AI models were widely available. So there are no longer sorts of typos that you can watch out for. You're not going to get a generic message, you'll get an extremely targeted one. But the things that it can't do are things that require mastery or where perfection is required. I think an analogy would be that you wouldn't really ask AI to paint the Sistine Chapel for you, but it's going to be able to create an endless stream of clip art for every presentation you'll ever make, and it can do that 24/7 without taking breaks. So yeah, I think another analogy is it's kind of, imagine if you had an infinitely scalable team of extremely sleep-deprived graduate students. You're not going to get perfection, you're not going to get mastery, but you will be able to get some results. So next slide. So based on that somewhat anecdotal evaluation, from a cybersecurity perspective, there are a number of technologies that are now at extreme risk of being obsolete because of these accelerants that have been applied to attacker behavior. Chief among them, we have great evidence already for bug bounties and phishing training encountering significant difficulty with today's availability of AI models. The incentives for bug bounties align perfectly that, for third world developing countries, the bounties that are available, $500, $1,000, are an extremely meaningful amount of money to many people. So it makes sense from their perspective to spam bounty submissions to whoever is willing to receive them. And because they're produced with an LLM, they sound reasonable, they sound confident, they sound like they could be accurate, and they might be to like an 80% degree, but only a highly paid expert can unravel the mystery of whether or not they represent a real vulnerability. And that mismatch in incentives is going to cause significant problems for the efficacy of these programs. Same thing for phishing training. ChatGPT knows who I am, right? It knows who many of the people in the room are. It's trained on the entire internet's data set. And you can ask it to write a perfect phishing message to reach me, and it turns out an extremely good result. You can ask it for 10 different copies and send me a new one every week until I get fooled. So this really implies that for all these things, for bug bounties, phishing training, signature-based defenses like IDS or antivirus, as well as threat actor attribution, all of these were attempts to deal with the problem without solving the underlying issue, right? We have code that's insecure. We have computers that when you hack them, you can take over a whole network. We have to actually address some of these core cybersecurity problems without fixing its effects with defenses like these. Next slide. So as a regulatory agency, one thing that you might ask yourself is, how can we regulate this problem away? Are there methods that we can apply to these AI models to force them not to produce these sorts of outcomes? And the answer is absolutely not. This is not an opportunity. Alignment will not save you. You cannot reinforcement learn your way out of the problem. And you can't restrict availability of AI models. Right? as of 12 hours ago, the best open source model that was available was completely conceived of, researched, developed, and then made available by a firm based in the UAE, completely outside of the United States. That's Falcon 40B, right? And these models that are available, that are open source, that are completely open to being fine-tuned by anybody for anything, are quite good. They start to compete with the availability of models like GPT-4 or Claude, et cetera. Now, these models, because they are so effective, because they've been trained on so much data, always within that data set are going to be the knowledge of how to commit crimes, of how to hack into things. And you can't unlearn that from the data set. Output censorship is really an unwinnable task that just frustrates amateurs and researchers. There's a really great sort of example, a reusable jailbreak, people call it, called DAN, Do Anything Now, which is a set of text you can drop into a bunch of different LLMs to get it to just invert its understanding of what it should do and should not. And this is also a really surprising result, that the more that you try to align an LLM, the more that you try to tell it what not to do, you're actually helping it build a model of that bad behavior, so that at some point in the future you can invert that understanding, and they're very quickly very good at the thing that you try to get not to do. People in the community call that the Waluigi effect. Let's go next slide. Now, all this is great, and it's based on a lot of empirical data that Trail of Bits has invested in and has performed on our own. But what we don't have is we don't have any kind of systematic measurement of what these models are capable of doing right now. A lot of the effort in the space is towards software programming. It's towards software development. How good is this thing at writing JavaScript or Python? If I have to change a form on my website, can it do it or will it break it? And these evaluation benchmarks are quite rigorous. They have thousands and thousands of tests. They're aware of specifically the information in those tests. There's just lots of capabilities and features that things like human eval or eval plus enable for us to actually measure progress of models like GPT-4 or Claude at writing code. However, we have no such taxonomy and no such benchmark for cybersecurity. We don't know if these models can solve one problem out of 1,000 that I deal with every day, and we don't know how that compares to state-of-the-art tools that I have available already, and we don't know how this might affect the daily work of a junior, mid-level, or expert-level cybersecurity engineer or hacker. So this is a major research area for Trail of Bits. But it also needs to be a community resource. It needs to be something that the financial community understands, so they can identify objectively whether their defenses are at greater risk or are now made obsolete by the availability of these models. So yeah, we know there's stuff it can't do. It's not magic, but there's a bunch of stuff it can really help with, and we just don't even know because there's no systematic evaluation. So next slide. So again, going back to the hype and the advertising, I think that there are right ways and wrong ways to build these systematic evaluation models, right? I think a lot of the ways that people evaluate LLMs right now is they ask it to pass, for instance, exams like the LSAT, the MCAT, the MIT final exams. But first off, a lot of these evaluations have trouble because that data is already in the training data set. You're just asking the LLM to regurgitate stuff that it memorized, which anybody can do. So you really want to know, does the output, what happens when you give it new problems, novel problems? And in order to create an evaluation metric that operates that way requires a lot of investment. You can't do these really cheap and simple things like download a bunch of final exams from MIT's website and pump them through an LLM. You also want to know if it can generalize past a few examples. You can very easily prompt hack your way into getting an LLM to answer one thing for you, but is that going to work time after time after time that I do it? And then finally, you have to deal with the fact that these things make mistakes. They hallucinate. They are not 100% accurate. They are probabilistic. They are statistical. They're not. They don't have actual knowledge of what you're asking it to do. So are mistakes acceptable, and will the task that you're asking it to do break because it does make a mistake down the line? So again, repeating the call, we need more measurement, we need task-specific data sets and evaluation frameworks, especially for cybersecurity. The sorts of questions that I ask it, like if I want to point it in the right direction are, is this technology, even if it's sort of feeble, remove a serious constraint that my adversaries or I had? So for example, crafting phishing languages in any language or at any person of any sort of social class or role within a company. How rapidly is it improving is something that I would like to know. So in the past, techniques around code synthesis were terrible, and now they're much less so. But at what point does it exist right now, and how fast might we get there? And then is there sort of a synergy with existing technology or tools? For example, what does the extreme pressure and the availability of GPUs have on adjacent technologies or other sorts of problems in cybersecurity? Right now, we're producing GPUs at an extremely fast rate. That field is advancing more so than it has in the last 10 years. And lots of companies have these giant clusters of tens of thousands of them. Are there other tasks that can be solved or that might be affected by the availability, the easy availability of extreme levels of compute? And then finally, are mistakes okay? Would be another, or easy to catch would be another metric that I would use to figure out if there's some fundamental change. Okay, next slide. So to wrap up here, AI is a systemic threat to cybersecurity. It changes the cost model for attackers and defenders. A lot of the ways that people are looking at AI to change cybersecurity is by magic. They think that it will be a Jedi mind trick, but it's not. It's going to augment human capability. It's going to remove constraints that attackers previously had that they no longer do. And if you try to fix this problem by leaning into alignment or control of model availability, then you're not going to be spending your time effectively. We need to create measurement and benchmarks that enable us to figure out how at risk we are and also what opportunities that we have. So from a positive note, when I look at attack and defense on cybersecurity, defense has a lot more problems that look like I have an infinite amount of data to sort through. I need some low-trained person to review it all, whereas offense has a lot more problems that look like I need to paint something like Michelangelo. Offense, you need to construct these articulate attacks that work, that are interpreted by a computer on the other end correctly in order to achieve the outcome that you want. So while I think the short term is definitely more geared towards offense, the medium to long term may be more geared towards defense. But in order to get there, in order to build defensive technologies that use AI, we have to be able to experiment with them. So a trend that I see among a lot of banks is that they've just made blanket restrictions on the ability to use a lot of these models and wanted to shove their head in the sand. But it's actually more important for us now to figure out how we can use these to aid our defense in order to keep up with attacks from the other side. So Trail of Bits has a number of resources that are available that directly address this topic. We have our published results from our trials of using AI to beat humans in auditing code for security vulnerabilities, a curated list of references that we believe help someone get up to speed on the field quickly. We also have our comments we made to the White House OTSP on how AI might affect national security and those sorts of problems. And then finally, we do also consult with people on how to improve the security of AI-based systems and increase the safety and security of new technologies that they have built, as well as techniques for doing so in that how to measure safety of AI-based systems link. But thank you, that's my talk.
Thank you so much, Dan. I appreciate it coming from a hard cyber background as well as a few other people sitting around this table. Really appreciate you examining the intersection of these two key priorities out of the three major areas for the TAC. And given the significant issues, so I'm just opening up the discussion with my own comment that I know that in the world of cybersecurity, there's just generally been issues with sufficiently measuring and understanding cyber risk, which led to issues like miscalibration of the cyber insurance sector, certainly continued challenges and debates about what the right metrics should be for key leaders to decide where to assert resources and defenses. And then also being a big sci-fi fan and coming from the military where we're thinking about what the future of warfare looks like and that actually there will cyber warfare will just be perpetual forever and will be AIs set against each other. This is the stuff that keeps me up at night. So thank you so much for the presentation and scaring us all, but also highlighting that there's a way forward if only we can get some of these steps right. So to focus on the defensive capabilities to be able to mitigate the risks presented by the offensive augmentation by AI. So thank you, Dan. I'd love to open to the rest of the TAC for their comments. I see Justin, you've got one. You can kick us off with a question.
Thanks for that, Carol. Great presentation. I guess I'm curious about why you're confident that this benefits the defense in the medium term. My understanding, and I'm not the expert that some of you are, is that cybersecurity has favored the attacker basically since we had wide use of the internet, that no one's really found a way for the defense mindset to catch up. And this strikes me as something where, based on your own example, attackers can make a lot of mistakes because you're fine with getting a very low outcome of success. A small number of phishing attempts, a small number of hacks can have high value, while defense needs to be nearly perfect. So what is the idea here that potentially could shift AI to using where defense is benefiting?
Yeah, sure. That whole, attackers only have to, defense has to win all the time, and attackers only need to win once. I sort of think about that a little bit as of a myth. Attackers actually have to enter a very treacherous environment once they break into a company. They're in a network that they've never observed before. They don't know what monitoring they're subject to. They don't know what's real and what's not. There could be canaries or honeypots or things that are put there strategically to distract or catch them. And then the tools that they work on are usually very expensive, articulate, require a lot of time. They're the Michelangelo, right? And those tools are very brittle because once the community is aware of what those tools are, if you report them to the vendor that exploits a zero-day, those tools go away. They disappear. They're instantly devalued. So from an attacker perspective, there are lots of different levers that you can put effort on in order to make their life hell. And with defense, I think the nature of defense is one where you have to think about breadth all the time. And it's really difficult for a human to pay attention to everything that's moving around an entire company. All the disparate data sets, all the different continuously streaming logs, all the different complex architectures of applications. And AI can provide a way to synthesize that and provide me an up-to-date picture all the time in a way that's nuanced, that has context. So I think that just because the nature of those two challenges, there may be ways to use AI much more effectively on defense to change this back into their hands after an initial period of what's going to be pain.
It sounds like what you're saying is that AI allows for redundancy to be dynamic in a way that's not the case right now.
Can you repeat that?
It sounds like what you're saying is that AI could allow systems to be redundant, defenses to be redundant and dynamic in a positive way that's not true right now?
Yeah, definitely much more dynamism. Definitely, it's really like, again, what could I do if I had an infinite number of sleep-deprived grad students? If I had an infinite number of, mediocre junior cybersecurity engineers, what would I be able to look at? What would I be able to inspect? What would I be able to review in real time that today I can't? Today that I have to have a batch process that only runs overnight, or that I have to have a quarterly meeting about. So I really do think that there's some opportunities here for defense. But again, in order to do this, we need to have a systematic evaluation of what these sorts of things can do, an anthropological understanding of what happens in the day of a cybersecurity engineer, what are all the technologies and techniques that they employ, and how does AI relate to each of them, and could it overcome constraints that they have? And right now we don't have that for cybersecurity, but we do for lots of programming. So we need to build analogous frameworks if we want to ever get there and achieve the upside.
Incisive comment. Nicole, next.
Here I go. Thank you so much, Dan, for that presentation, and appreciated just the conversation of cybersecurity and AI and that intersection. I do have a question on how do we keep these systems updated? Because what we also know is that AI, once people are sort of onto the AI, change the AI so that we're always evading those types of cybersecurity mitigation strategies you discussed. So just curious, is it documenting? Is it being a step ahead? How do we do that when we as policymakers and innovators are always behind?
Sure, so I can answer from a technology perspective. I mean, we need to fix the root cause problems. Like, phishing education was just a Band-Aid on top of the root cause problem that when somebody in your company gets hacked, it can bring down the entire network that you own. That should not be the case. It should never have been the case. Authentication should have been strongly authenticated. There should be limited information available on that person's machine. You should have authentication by or authorization by context. You need to have an incident response procedure or a minimized sort of blast radius of when a hack happens. What is the worst thing that can occur inside the company? It shouldn't be that I can hack an executive assistant at Coke and then steal the formula for Coke, right? Like, these things should be isolated, and your company should be safe no matter what emails people click on or what documents that they open. So that's the thing that I think we need to get back to. I think that we need to really ask ourselves these hard questions again of, are we just sort of distracting ourselves from the root cause problem? Are we putting a Band-Aid on the issue? Or have we ultimately addressed this risk in some way?
Thank you. If there's no other questions, what a way to wrap up a fantastic discussion of 2 of the 3 key priority areas. Again, thank you so much, Dan, for the great presentation and for the really insightful questions. So now